In this video, I'll show you how to become a pro at Retrieval-Augmented Generation, also known as RAG. You'll learn what it is, the 3 ways to use it, and see examples for each. Now there's a lot to cover, let's dive in. So what is RAG? RAG stands for Retrieval-Augmented Generation. It's the process of retrieving information to augment or modify a generated response. How does this work? When you have an AI model has a context window, which is the amount of input tokens that it can take to then give some sort of response based on those input tokens. If you don't give it any additional context to start and you begin a conversation with an AI model, it's only going to respond based on its training data. But as you start a conversation with that AI model, there is now conversation history. You have a prompt, it has a response, and that same prompt and response, the next time you prompt it, is going to be sent to the AI model, so the AI model has the additional context that is the conversation history when it responds. So now it can respond keeping in mind how this conversation has been going. So it's got its training data plus its conversation history to help it respond. Sometimes we want to guide AI models to be particular in the way that they're responding. So sometimes when we create AI agents, we'll create an AI agent with specific instructions, or sometimes we call it a system message, at the very start so that it knows how to begin responding right when you start having a conversation with it. And now, anytime a conversation occurs with that AI agent, it'll always have the instructions that you gave it to consider in its response. It'll always have the conversation history as it gets larger to consider in its response, and this will be all in its overall context window. Now this is great, but what if you have knowledge that's elsewhere and you want your agent to be able to access it to change the way it responds? Say you have this knowledge A in some database. Well, first we need some sort of way to tell our agent how to get access to that information. This is usually behind the scenes or underneath the hood. In code, it's part of the setup or SDK to connect to a knowledge base or a tool. In Microsoft Foundry, this will be how you can configure your specific tools in the portal. But we need some sort of instructions that'll tell us how to connect to that database. Once that database can get connected to, there's got to be some sort of orchestration logic that makes this happen. The knowledge that is behind the scenes shows how to use that orchestration logic to get information from that knowledge and send it to the AI model so that the AI model now has additional context from that knowledge or from that database so that it can then respond. Now, it's going to respond based on that new context, and that's augmenting the response that it'll have based on the retrieved data. This is Retrieval-Augmented Generation. So this is RAG. When you have that knowledge or data outside of your standard conversation flow, outside of that standard context window, to get information and bring it back to the AI model, add it to the context window to then respond. So now there's 3 ways you can do RAG within Azure. 1, there's file upload. 2, classic search. 3, agentic retrieval, which is also called Foundry IQ. Let's go over them briefly, and then we'll get into all the demos. File upload is where you'll upload files to the Microsoft Foundry portal, or in code, you'll set it up, and there will be behind the scenes a Microsoft managed AI search resource that vectorizes the data that's uploaded so that it can be quickly searched and sent back to the AI model. Classic search is where you'll have an Azure AI search resource, and you'll have data in some sort of data source, and that data source will take that information and give it to your indexer to index the data so that it can then go into a search index. That search index, when information is prompted from your AI search by your AI model, it searches the index quickly finds whatever it can based on the query and sends it back to the AI model with the results. That is how RAG works with Classic Search. The last one is a more advanced, newer version of what Classic Search offers. It's called Agentic Retrieval or Foundry IQ. This uses what's called a knowledge base and a large language model for retrieval reasoning. What that means is that you can have multiple knowledge sources that might have an indexer or an index, or another indexer and an index and a different knowledge source. You could also have different knowledge sources, and your large language model that is associated with your knowledge base actually chooses, based on the query that comes from your AI agent, it chooses what knowledge sources to search through to get answers that it can then send back as context to your AI agent. So this is another step that can be helpful in determining what information comes back. This is the most modern and newest way to do RAG in Azure. Now, you might have spotted something that they all have in common. File upload, Classic Search, and Agentic Retrieval, they're all using Azure AI Search behind the scenes. Azure AI Search is a cloud service that transforms data into AI-powered searchable insights. So just so you know, this is what your AI agents are using to do RAG in Azure. If you want to learn more about Azure AI Search, I created a complete masterclass that you can get access to here and in the description. Now let's get into our 3 RAG methodologies, starting with file upload. I'm in the Microsoft Foundry portal. You can get to this by going to ai.azure.com. Within this project, let's create a new agent. We'll call this File Upload Agent. My agent's created. Let's give it some instructions. You're a helpful agent that only uses your file search and file upload tool. You never use your own knowledge, and you always give references to the information that you find and provide to the user. We'll save this. Now we'll go to Tools, add a new tool, and I'll choose File Search, add this tool. And now I can upload files that are going to be used for my agent to retrieve the information and augment its response based on these files. For reference, we're going to use these 3 JSON files: frequently asked questions, policy information, and recipes.json from my Frankie's Bakery fictional bakery company. Let's drag these files in. They'll all upload. I've seen this error before. It still works. Ignore it if you see it. I'll attach the files, and we'll save this. Now let's give it a try. What is Frankie's Bakery's cookie options, and what is their freshness guarantee? It comes back, it gives a response, and it has several references with it. I can see the recipes.json reference, I can see the frequently asked questions, and the policy info. So it used all of the files that it retrieved when I asked it to prompt it with something, and it came back and augmented the response that it generated. That's RAG. It's using the file search, file upload feature, and now you can use it too. For your Azure AI agents, take advantage of this fastest way to use RAG. File upload is the fastest way to set up RAG for your Azure AI agents, but you give up a lot of control for the sake of that speed. Let's look at using Classic Search, which gives the control back to us and gives us a more robust RAG architecture. Let's set up Classic Search. I'm in the Microsoft Azure portal. In this resource group, that's a new resource group that has a single Microsoft Foundry project. Let's create our first set of resources for setting up Classic Search, starting with the storage account. We'll type in storage account, and begin creating it. Let's give it a name. We'll choose Azure Blob Storage. Primary workload will be artificial intelligence. Performance standard will make the local redundant storage. No need for geo redundancy. We'll review and create, leaving the rest of the defaults, and create our storage account. Our resource is complete. We'll go to it. Then we'll go to Storage Browser, Blob Containers, and create a new container. We'll call it Frankie's Bakery CS for Classic Search Container. Then create. We'll go into the container and upload some files. For reference, the files we'll be uploading is the recipes, policy, and FAQ JSON files that we used in the file search example. I'll add these files and upload them. My files have been uploaded. Now let's go back to our resource group, and we'll create our Azure AI Search resource now. Create AI Search, Azure AI Search. We'll give it a name. We'll select the pricing tier. This is where you need to be careful when it comes to using Classic Search or Agentic Retrieval with Azure AI agents. It costs a lot of computing power to make Azure AI Search quickly search and retrieve through a lot of information all at once. Because of this, Azure AI Search can be pretty expensive. If you're using it for a short period of time, make sure to delete the resources after. If you're using it long term, make sure to factor in the cost. We'll just be using the basic tier, so I'll select that and we'll review and create, leaving the rest of the defaults. My resource is done being created. Now we'll go to it. Now just before we import our data, let's create a text embedding model in our Microsoft Foundry resource. We'll go to Discover, Models, and search Text Embedding. We'll find Text Embedding 3 large, and we'll deploy this model, leaving it with the default settings. Now that that's deployed, we'll come back to our Azure AI Search resource, and we're ready for our next step to create our Azure AI Search resources using the Import Data Wizard. So right here, this is the Import Data Wizard. We'll choose the new version, the one that has new here. Select this. And now these are some of the options that are available to import data for this Azure AI Search resource at this region. Depending on your region and SKU, you might have some more options. We'll be choosing Azure Blob Storage, RAG, and now configuring this to create our Azure AI Search resources. Select the storage account, the blob container. You can be more specific with a folder in your container if you'd like, and select your parsing mode. I'll leave it as default, which collects all the text from the documents and vectorizes them all into set chunks. I won't enable deletion tracking, and I won't authenticate using managed identity. Next. Now we need to plan how to vectorize the text so that we can create vectors, and this is what our text embedding model will help us do. So we'll select Azure AI Foundry, which is the old name for Microsoft Foundry. Then we'll find our project. Select our deployment, which is our text embedding. I'm happy with the API key. I'll acknowledge that this will incur more costs because of the input and output tokens for the text embedding model, and move on. We won't be vectorizing images or enriching data with AI skills. We'll move on. We'll leave semantic ranker because when search results are captured and come back to Azure AI Search, semantic ranker will re-rank them again based on the semantic meaning of the prompt or queries that originally came to Azure AI Search. You can preview your index fields and decide how to schedule indexing. If data keeps being added to your blob storage container and you want your index to be up to date, this is what you'd use your schedule for. If you're only adding data once, like we are for this example, we'll just leave it as once and hit next. Now we'll name our index in Azure AI Search. I'm going to call this Frankie's Bakery CS Index and create it. Our resources are creating. I can start searching. Now I probably need to wait just a moment for the indexer to run, but in just a second I'll hit search and start to see some data come back. This text vector is a large high-dimensional numeric vector that represents this chunk of data. And to see this data come back more easily, I can come over to Fields. I can click this Retrievable checkbox for text vector, meaning I don't want to retrieve this data in the Search Explorer. I'll save this, and I'll select Search Explorer again. Then search, and I'll see the data come back again. This is an example of seeing how search queries will work when we make queries to Azure AI Search. Now, right now we're viewing the index that we just created. Back in our Azure AI Search service, let's review our indexes. We see the index, our indexer that just got created, the data source that just got created, and the skill set that was just created. Now that we have our skill set, data source, index, and indexer all created, we can connect this up to our Azure AI agent. Back in the Microsoft Foundry portal, let's go to Build and create our first agent. We'll call it Classic Search Agent. We'll give it some instructions and save it. These instructions tell our agent that it's a customer support agent that will use its Azure AI Search tool. It'll never use its own knowledge, and if it can't find something, it'll say it doesn't know. It also asks to give the references from its search results. We'll go to Tools, select Azure AI Search, add Tool. Now we'll have to create a connection to an Azure AI Search resource. Select our Azure AI Search resource. Select Authentication Type, which we'll choose API Key. Now select our index and add it. I'll save this. I might need to make sure that this is added. Now I'll save this. Now let's give this a try. What can you tell me about Frankie's Bakery and its products? And we see it tells me about some of the information it has available, and it gives references to the blob storage links. This is an example of how you can set up and use Classic Search for your Azure AI agents.
Classic Search gives you the power to control your data the way you want, but it still has limitations. So Microsoft created Agentic Retrieval to give you the best of what Classic Search offers, but without its limitations. Now let's see how to set up Agentic Retrieval, also known as Foundry IQ, so you can use that now.
The way Agentic Retrieval is set up is first you'll create your Azure resources. You'll create a storage account with a blob storage container within it and add the data that will be relevant to your agent within that container. You'll then create an Azure AI Search resource and create a Foundry project, an agent, and deploy a text embedding model in Microsoft Foundry that will be used to vectorize data later. You'll then create a knowledge base and a knowledge source. You can do this in Microsoft Foundry, or you can do it in your Azure AI Search resource. Ultimately, those are both going to be in Azure AI Search, and when you create a knowledge base, you'll be required to create a knowledge source. As you create a knowledge source, the other resources for Azure AI Search will be created as well. A data source will be connected to your Azure storage account, and that data source will also connect to your knowledge source. You could have multiple knowledge sources for one knowledge base. Finally, you set up Foundry IQ for your agent, and Foundry IQ will then connect to your knowledge base. The way Agentic Retrieval works is first a user will send a prompt to your agent. Then your agent will decide whether or not to use Foundry IQ. If it does, it'll build a search query and send it to Azure AI Search. It might also contain multiple subqueries. You also might need to approve this because Agentic Retrieval uses MCP protocol, which may require your approval in your chat window. If it's approved, then it'll send those subqueries to Azure AI Search, which will begin Agentic Retrieval. Agentic Retrieval involves an AI model that's associated with your knowledge base that'll first reason and decide on which knowledge sources it should use for each subquery. It'll then run all of those queries in parallel, and if it's not content with the results it gets back for each one, it might even try to reason on which other knowledge sources it should check again and run more queries. Once it gets back enough results and it's happy with them, it'll merge them all together and rank all those results. And then depending on how you specify your output for Agentic Retrieval, you'll either get the raw ranked content from all of the search results, or you'll get some summarized results that are sent back to Foundry IQ in Microsoft Foundry. Those results are then injected as context into your Microsoft Foundry context window, and then your agent generates an answer and response to the user. All right, I'm in the Azure portal, and in this Azure portal, I have this new resource group that's set up. All it has is a Microsoft Foundry resource with a Microsoft Foundry project. I've got my Microsoft Foundry portal with the project pulled up over here. So the first thing we're going to do is create our storage accounts. We'll go to storage account here in the resource group. If you don't want to have to create all these things, you can skip ahead with the chapters to get into the meat of when we're creating Foundry IQ. So we'll create our storage account. We'll name this Azure Blob Storage. Primary workload will be AI. Leave standard. We don't need geo redundancy. I'm just going to choose locally redundant, and we will leave the rest of the defaults and create our storage account. Now to talk about our use case here, I have a fake bakery called Frankie's Bakery that has policies, has frequently asked questions, and recipes. And those recipes are for products that are used in Frankie's Bakery. We're going to take files for the frequently asked questions, some policy information, and recipe data that I have, and those are going to be the pieces of information in JSON files that we're going to upload and we're going to query on. My resource is done being complete. Go to our storage browser and our storage account. Go to blob containers. And now let's add a container. So because we're going to use Agentic Retrieval, also known as Foundry IQ, we can search through multiple knowledge sources, as opposed to classic search when you're using Azure AI Search for RAG, where you can only search one single index with your Azure AI agent. Because we can search multiple, we're going to have 3 different containers to simulate having multiple different knowledge sources so that we can see Foundry IQ really in the works. All right, so we're going to have Frankie's Bakery FAQ. Frankie's Bakery policy info. And Frankie's Bakery recipe info. We'll just call it recipes. All right, so now for each one of these, I'm going to upload this data. For your reference, here's kind of like what some of this data looks like here. We've got recipe name, some descriptions, ingredients, policy info, just some content, and some FAQ questions there. So those are the 3 JSON documents that we're going to be uploading. I'll bring this in, upload it. Go to our next policy, upload. Bring that in. Recipes, upload. All right, now we have 3 different containers, each with a JSON file in there. Now our next step, let's go back to our resource group, and we're now going to create our Azure AI Search resource. I'll type AI Search, create an AI Search resource. Let's give it a name. Okay, you want to be aware that when it comes to Azure AI Search, it can get pretty pricey pretty quick. There's a lot of power and compute that goes into being able to store and vectorize a lot of information and then quickly being able to query and search through it to then send back results that are relevant and high quality. Because of that, Microsoft has to have a lot of resources themselves, and so it can get expensive using Azure AI Search. So you want to be super aware if you're going to use Agentic Retrieval or Foundry IQ, you either need to factor in the cost of Azure AI Search or just use it on a temporary basis where you have an Azure AI Search resource that you spin up and destroy and only use when you're actually using the service itself. You probably need infrastructure as code for that, but otherwise you'll have a permanent solution, and you just want to factor in how much it's going to cost. Use Azure Cost Calculator or Azure Pricing Calculator to come up with that information for your use case. In our circumstance, I'm going to choose Basic here, which is $75 a month per search unit, and we'll keep going. Then I will leave the rest of the defaults and create the search service. All right, my deployment is complete. And now let's head to Microsoft Foundry to set this up. So I'm in Microsoft Foundry. I'll go to Start Building because I'm going to create an agent that will use this. We'll call it our Agentic Retrieval agent. Agentic Retrieval agent. I'm going to give it some instructions and save this. And now let's set up our Foundry IQ. So add, connect to Foundry IQ, connect to an AI search resource. This will jump us to the knowledge section within the build page where we can get started setting up our Foundry IQ. I'll come down to select our resource now. Here we are. I'll leave auth type as API key and connect. Now we can create our knowledge base. Of the knowledge bases, or for my knowledge base, I can have different types of sources. Now, these are just a handful of the sources that are available because we have our information in a blob storage container. We're going to choose Azure Blob Storage. But if you did have information that you wanted to use as a knowledge source on SharePoint or OneLake, you could use that as well. You could also just connect an existing Azure AI Search Index as a knowledge source, or even search the web. So there are a lot of options here to play around with. We're going to choose Azure Blob Storage. Now I'm going to call this, let's do this for Frankie, knowledge source, Frankie's Bakery. FAQ. The description here matters. This description is going to help the agent, or not the agent, the LLM that is associated with your knowledge base that is used to decide which knowledge source it should search for a query that comes to it. It's going to decide which one to use based on the description. So this description, you want to just be clear on what is in that knowledge source, or if it's like a web knowledge source, you want to say this is to search the web, so that your LLM, when it's deciding, it knows, hey, this is the one to use. So in this circumstance, I'm going to say Frankie's Bakery, frequently asked questions, just so it's aware. Then I'm going to choose the storage account where this is. I'll choose a container, leave the authentication type. Content extraction. So content extraction, this is for when your index, indexer, skill set, data source are all being created in Azure AI Search. This is talking about how much data do you want to have extracted from your external data source to be added to your index. So if it's minimal, it's not. It's just the basic information that you need. If it's standard, you might get more richer metadata. If there are images that are within your data that need OCR to be done, and all of the descriptions involved with those images needs to be added into your vectorized data, you might use standard for that. Our current region and tier don't allow for this, so we can't use standard. We're just going to use the minimal, and that's okay. But that is a circumstance when you might need standard. Is just when you need more richer data that needs to be extracted from your external data source to be added into the index that's going to be used for your knowledge source. Embedding model, it says include embedding model recommended. That's because if you don't have to have an embedding model, but if you don't, then you can't create vectors in your index. And when this knowledge source is being searched, it's being searched using keyword search, which is not quite as rich as vector search or hybrid search, because you lose the semantic meaning of the data and the text. So we want to have an embedding model that can vectorize our content in our blob storage account into our index that will be actually searched for our knowledge source. So embedding models, I don't have one right now, so I'll browse models, see the embedding models. I'm going to choose text embedding 3 large, which if you're not sure what an embedding model is, this is just a special kind of AI model that is designed to look at text and change it into vectors so that it can be a vector embedding. It has all of the semantic meaning associated with words and text and content. So that's the focus of these types of models. So we're going to deploy this text embedding 3 large model. Now we'll select it. Now this chat completions model here at the bottom, this is for another part of the data extraction and creation of your index in the Azure AI Search side. So this Azure OpenAI deployment for image, verbalization, context extraction. Imagine talking again about the content in an image. If you wanted to have a chat completion model that can summarize the information on that image, this is what that model is going to do. So it creates more rich context data. We don't have images in our data source, so we don't need this. That is something that's unnecessary. And then the advanced options, this is if you needed your indexer in Azure AI Search to run more often, if you kept adding data to your knowledge source, the external knowledge source, in our case, the blob container, if there was more data being added on a regular basis, we'd want our indexer for our knowledge source to be running more often. And this is the ingestion schedule that we would set in the time. And then the folder is just the specific path if we have more specific paths in our blob container that we need to specify. We'll leave the defaults for that and create our knowledge source. All right, that's being created. I'm going to speed up and quickly create the other two just so that you don't have to see all of the typing. All right, now our three sources are active, or this one's being created, the policy info still. Let's take a look at the rest of the information in our knowledge base. First, we're going to add a name. We're going to call it Frankie's Bakery. I'm going to prefix it with knowledge base so that we know Frankie's Bakery. And we can give it a description as to this description is for what it is, just for anybody who's using this in the organization, so people are aware. This is not going to be relevant to the usage of it, so I'm just going to leave it blank. This chat completions model now that we're going to select, GPT 4.1, this is the large language model that's going to make decisions on which knowledge sources to use when the knowledge base needs to specify which sources should the subqueries be mapped to. So when you prompt your agent and the queries or subqueries come to this large language model, it'll decide between all of your knowledge sources when it is specifying which ones. So retrieval, reasoning, effort, there are three options: minimal, low, medium. If you choose minimal, all of the knowledge sources are going to be searched anyways. If you're choosing low or medium, this is where your large language model is going to decide which sources to use. It might not decide to search all of them just to be more efficient and quick. If you choose over here the output mode, there's extractive data and answer synthesis. Extractive data means the model is going to take all the subqueries that come from the Azure AI agent, and it's going to make those queries, it's going to get information back from your knowledge sources, and then it'll have a large list of sources and information that can be injected into the context for your Azure AI agent. And extracted data is going to just give all of that information to the agent, and then the agent needs to synthesize, summarize, and take all that information and use it however it sees fit. If you choose answer synthesis, then the chat completions model in the knowledge base is doing some additional summarization itself by synthesizing the information it gets when it does those queries on your different sources. If you're going to do answer synthesis, you have to have the low or medium retrieval reasoning effort. If you also want, you can have retrieval instructions, which will tell your chat completions model some more information as to which sources to check or look at if your retrieval reasoning effort is at low or medium, and not all sources are going to be used. I'm going to leave that blank because I want to save this and show the knowledge base searching with all of the sources, and then we can come back and see answer synthesis with the reasoning effort different. So I'll save this knowledge base. Then let's go to our agent and connect this. In our playground now for this agent, we'll come to memory, add, connect Foundry IQ, connect our knowledge base. And now we see this set up. Let's save it. Now I'm going to give it a prompt. This is to ask for information that I know should be related to all three of the different knowledge sources. Foundry IQ, or Agentic Retrieval, is using MCP protocol. Because of that, it's going to ask for our approval in order to run this. You can approve it once, multiple times. If you don't want to have to approve every time, we're just going to keep approving one time each time. So these are the subqueries that are going to be sent to our knowledge base, and the agent is going to pull information from our knowledge sources. So we see information on chocolate chip cookies, which is what I asked about, some storing information, freshness guarantee. I can come over to this debug within our agent's playground. I can see the tool call, and in the inputs and outputs, I can see the input of what was sent to the tool, and I can see the output. So this output, we see that it retrieved 7 documents, and then we see some of these sources. So this is the sources, the information that came back from the indexes in our Azure AI Search instance. And we can even see the blob URL that is associated with this particular source ends in recipes.json. So we know that this is information that came from recipes.json. And now we want to see if there is data that came from each of our sources. So we see recipes again, frequently asked questions, FAQ there. Now we're just looking for policies and policyinfo.json. So now that is showing us that this big chunk of output that our agent got, this is all coming from the tool. This is information from 3 different knowledge sources that our knowledge base sent back to our agent so that the agent could then take this information and use it to further answer our question. This is Foundry IQ being used to its full potential. Now let's take a look at that answer synthesis. Real quick, in the debug mode, what we're going to be looking at in the answer synthesis is right now in this tool input output, we see that this UID with this long UID name and the blob URL, the snippet, this is all the raw content that's coming from Azure AI Search when we search the indexes. When we do answer synthesis, we should expect at the very top of here, we might get some of the raw information, but we should expect at the top a synthesized answer from the large language model associated with our knowledge base so that our agent doesn't have to work as hard to summarize or synthesize the data that's coming back themselves. So let's add that capability, go to our knowledge base. We're going to go answer synthesis. We'll see our retrieval reasoning effort automatically changes because it can't be minimal. We'll make it medium. And we could add additional custom guidelines if we want on how to format the answer. I'm just not going to. I want to just show you how it works with the answer synthesis without the additional setup. We'll save this. We'll refresh the page so that the agent has a moment to understand that the change has been made. Sometimes you do it too quick and it doesn't pick up on the change. Now we're going to send that same thing and look at the details and see the answer synthesis. We'll approve the call. All right, we got a bunch of info that came back. We'll check the debug. And if we check this tool, we see at the very top here, this right here, this is our answer synthesis. This is the summarized information from our large language model that's associated with the knowledge base. It's the agent that is doing the agentic retrieval for us. So this is our synthesized information that's coming back to help our agentic retrieval agent more easily answer our question. This is Foundry IQ.
Those are the 3 ways you can use RAG for your Azure AI agents. If this video was helpful for you, I'd appreciate it if you liked it and subscribe to this channel if you want to see more content like this. If you have questions, leave them in the comments below. I answer every comment to help as many people as I can. If you want to learn more about Azure AI Search, you can find the complete Masterclass video here. As always, thank you so much, and I'll see you in the next one.